what seems to be the hardest thing for students to figure out in writing their own procedures is how are you going to create 10 different saltwater solutions of different concentration without changing the volume of the solution. That's to say, you want to have 10 solutions with different amounts of salt, but the same amount of solution. Now let's be clear about what a solution is. A solution is made of both the salt and the water, or the salt water solution is made of both of those things. So the way that you go about doing that, you've got to have different amounts of salt, and it's just common table salt we're using here. And we want to measure out the amount of salt that we need. Now, this is a digital balance, and you can zero out the balance. You can put the container that you're measuring the salt in on the balance and press the 0 point on the balance. And then when you put the salt in here, it'll measure only what's in the cup, and it won't also give you the weight of the cup itself. So let's say that I want a solution that has 90 milliliters of water, or solution rather, in here. Now this is a 100 milliliter graduated cylinder, and we don't want to try to measure 100 milliliters. The reason is you never go all the way to the top. There's a problem with trying to measure the actual amount that's at the top here. So we want to only have, say, 90 milliliters, and make all 10 solutions. If we're going to do 10, all 10 solutions will have 90 milliliters of solution. But if we just put 90 milliliters of water in here and we add salt to it, well, that's going to change the volume. So the way that we do that then is to say start with, okay, what I've got is approximately 73 or 4 milliliters of water, and I'm going to put this in a different container because I want to keep that dry for measuring salt. So I'll get out. I should dry this out and wash it and dry it out very carefully. So I'm going to put the salt in here, and I'm going to put the 70 something milliliters of water in here, and I'm going to dissolve it. I'm going to use this glass stirring rod for dissolving it, and it takes a little while to dissolve all the salt. Could use a plastic spoon or something. Nothing special about a glass stirring rod except that it's the thing that we most often use in the lab for stirring. I think that's pretty well dissolved. Now, you notice I'm trying to make sure all the drops of water are off of here. And I don't want to put this stirring rod back on the lab table because I might get it contaminated. I'll lay it on a paper towel here. Now I'm going to put the 70 milliliters back in here. And I've got a few more 70 something. I've got a couple more milliliters now of solution in here. So what I'm going to do is, this is a distilled water container, and we always use distilled water in the lab. And I can put some more water in here to try and rinse out, make sure I've got all the salt out of there. All right. And now I can very carefully put in enough drops here that I get to exactly 90. Now, I'm just trying to show you this. I went a little past it. I'm going to start making this 95 instead. Very carefully. So I've got just the right number of drops. I've got this little white card that has a black bar on there. And I'm going to use that to put it behind here so I can very clearly see where the meniscus is. Also, I want to stir up a little bit in here. If I try to stir the salt inside the graduated cylinder, it'll take forever because it's so narrow. That's why I dissolve it in a beaker first and then put it in here. Okay, and so let's see where we are. We still don't quite have enough water in here. And you might be able to see how this black card with the black line allows you to see where the meniscus is in the bottom here. All right, so I've put some water in this graduated cylinder, and I'm going to use this card to show you how it helps you to see where the bottom of the meniscus is. So if you look, telling where the bottom of the meniscus is a little bit difficult here, but if I put this card in here, look at how it makes that meniscus sort of show up. The bottom of that curve in here shows up really well when I put that black card behind it. Okay, and you can tell exactly where that measurement is. But that looks like 95 there. You want to be right on 95, and we're going to do 95 every time. So now I have a 95 milliliter solution of water. I know the exact amount of salt I have in here. So now I need another container in which to weigh the solution. So I'm going to put this container on here. I'll zero out the counter, the balance, and then we can measure out that 95 milliliters of saltwater solution with a known mass of table salt. And so the next time I'll do the next solution in the same way. I'll measure out the salt first in a container. I will dissolve it in a beaker. I'll stir it up really good. I'll put that small, it's not less than the 95. You need to start about 20 milliliters short of what you want it to be eventually. And then drip some water in there so you get the exact volume every time. And that way you can have a consistent volume. Now, the reason we do that is when you're doing testing like this, you want to have all the potential variables controlled that you can. So we're going to control the volume because that's a possible variable. The only two variables we want to have changed are the amount of salt we put in each of these 10 different solutions. And we want to see how that affects the density. And so now that we know that we have 95 milliliters the same every time, we haven't changed the volume, but the density should be changed. We're measuring the mass of the solution now, and we have the volume of the solution. You divide the mass by the volume, you get the density. And so you compare these 10 different concentrations of salt water to see what's happening with that and put it on a graph and determine what the difference is, what difference there is in the different concentrations, what the difference of the density is of the different concentrations. And then you're going to compare at the end a sample of water from this estuary, and then typically I give you that sample and you use that standard curve to figure out what the concentration of the salt water is in the estuary.